theoretically, you should have learned some of this in middle school, but we all know what a hot mess and dumpster fire for some of us middle school was. So we are going to either learn, or in some of our cases, review, okay, how to write various situations that involve inequalities 4 different ways. I'm going to remind you about the ways you should have learned in middle school, and if you didn't learn it the first time, you'll get to see that. And then I'm going to show you how now we represent it here in high school. So for each example, I'm going to make kind of like a little table that has like 4. So you want to probably do that too. Just draw yourself a little 4-section table. So draw yourself like a little 4-section table with 4 separate sections. Okay? And what do we refer to when you hear the word unequal, what are you thinking about?
Greater than, less than.
Greater than, less than, right? Like not equal to each other. Even though, as you're going to see in a second, there is an element of something being equal to it. Okay, so the first thing is we're going to write the verbal representation of, so in the top left-hand corner, I'm going to write the verbal representation of my first example, okay? So my sister will bug me for at least 60 minutes. Okay? My sister and I one of my sisters and I are extremely similar, which sometimes I think makes it kind of bad because we're almost too similar. So we get on each other's nerves a lot. I was actually just thinking of this example first thing this morning because we're going to be leaving for Thanksgiving pretty soon to go visit our dad. I'm going to be in the car with my sister for a hot minute. That stresses me out about how much she's going to end up getting on my nerves. So this is the verbal representation of how my sister will get on my nerves for at least 60 minutes. If I want to turn this into an inequality, and I'll bet you guys are going to remember this, I'm going to use X to represent how long my sister is going to get on my nerves. And by the word the words, I should say, at least. Remember that means that she could get on my nerves for 60 at a bare minimum. She's going to get on my nerves for 60 minutes, but it could be more. Okay? So the way we're going to represent that algebraically is X is greater than or equal to 60. We all remember that from early, like I'd say probably late elementary school, early middle school. Alligator eats what's bigger. So since my sister, she'll get on my nerves for at least 60 minutes. Because it could be 60 minutes exactly. That's why we're going to do the equal sign. Okay? And because she could get on my nerves for more than 60 minutes, that is why we're going to use the inequality symbol of greater than or equal to. So is this ringing a bell for folks? Great. Yeah. Okay. Now, when you should have learned this part in 6th grade. Adding on what you should have learned in 7th grade, although again, 7th grade, was kind of when the world started falling apart. That's when you should have learned, emphasis on the should, theoretically, when you should have learned how to graph an inequality on a number line. And I'm not picky, honestly, about like how long you make your number line, how many numbers you put on it, okay? But so I'm just going to put my number that I'm interested in, which is 60, okay? And what you do to graph a number on a number line is you put a circle around it, and you have to make a decision about whether you're going to color in that circle or whether you're going to leave it not colored in.
When it's colored in, it means it's equal to, right?
Yes. Calvin, he stole the words right out of my mouth. Okay, this particular inequality involves an equal to. So that is why, friends, you are going to actually color in that circle. And I'm going to make a little note. This is what, in the same color, the math term for filling it in is called closed. And if you don't fill it in, we call it open. And the reason it's closed is because there's an equal to sign underneath that inequality. So exactly what Calvin just said, and I'm going to color code all that. So because there's an equal to involved in that inequality, that means you need to fill it in, which again is called closed. We also need to represent the fact that technically she could get on my nerves for more than 60. She could get on my nerves for 61, 62, 64.7. Theoretically, she could get on my nerves for 1,000,000 minutes, really. Now, granted, nobody has that much time, of course, but theoretically, any number on the planet that's bigger than 60 could be part of my solution set. So because x is greater, we are going to take our little pencil and we're going to darken the right side of the number line, and that's called shading to the right. And the reason we had to shade to the right was because that inequality symbol was greater. So 2 pieces to the number line. You got to decide whether to color it in or leave it open, and you need to decide whether you're going to shade to the right or whether you're going to shade to the left, because you need to shade indicating greater than or equal to. I'm sorry, greater than or less than, my fault. So all of this theoretically should be review, although again, I know we're all kind of, in different places. This last part, I've literally never met a kid in 9th grade math, or in honors anyway, who's known how to do this next part. Most middle school teachers have not taught this, so this is one thing that will definitely be new. So I'm going to zoom in here a little bit. And we're going to do something called, wrong word, interval notation.
I know what that is.
You do?
I think I might know what that is.
You will be the first. So the interval notation is when somebody can just look at the 2 numbers and see like where your numbers start and where it finishes. So what you do is you take, and I'm going to use the number line actually to help me. You take the smallest number in that set of numbers. So look at our inequality. 60 is the beginning point, right? If you look up at the number line, you see it starts at 60. So you start with your smaller end first, a comma, and the larger side of your interval, okay? Now, what exactly does that yellow arrow mean? That yellow arrow means it's going like forever and ever and ever to the right? So whenever even though we know in real life, technically my sister isn't going to get on my nerves for like 1,000,000 hours. We're still going to say it anyway. It's a possibility. Whenever something goes forever and ever and ever in a positive direction, we use an what symbol is that?
Infinity.
That's an infinity symbol. Exactly. So in order to do interval notation, looking at the number line is very helpful. So you see it starts our interval where all of our solution set are. It starts at 60, and then it goes all the way forever and ever and ever in the positive direction. So we also have to add brackets, and yes, the type of bracket that you put around it matters, okay? So let me zoom back out here to my inequality symbol. We are going to put a square bracket around the 60. And again, the reason we're going to use a square bracket is because it's an equal to 60. Basically, a square bracket means exactly the same thing as filling in your circle. They actually mean exactly the same thing. Coloring the circle in is the number line version of what you need to do. Putting a square bracket around the 60 is the interval notation version of saying that it's equal to. Now, infinity is technically more of a concept than it is an actual number, okay? So you're not going to put you will never, ever put a square bracket around an infinity, because infinity is an idea. It's not exactly like an exact number. So you are going to use a parenthesis, like that's like just a round parenthesis because it's not equal to, because again, infinity is more of a soft parenthesis. So you can't have something equal to infinity because that literally infinity is not a real number. It's just a concept. So if you look at your number line, you can figure out pretty easily what your interval notation needs to be. If it's shaded to the right, you know you're going to have a negative infinity. If it's shaded to the left, I'm going to show you that in a second. So square bracket, because you've got it colored in. And then the parenthesis, because it's not equal to. So those are the 4 different ways you're going to be asked to represent an inequality. You need to know in words how to write it using an inequality symbol, a number line, and interval notation. This will be a pretty short unit, by the way, so this one's only going to be a couple weeks, so we'll have a test over this fairly soon because you're really not doing a whole lot new besides this part, to be honest. Most of it's pretty similar to equations. Yep.
So basically, instead of doing the equation, we're just going to be writing this out?
Well, you are going to be doing this, and then later we are going to write an equation too. Inequalities are actually, like, in my opinion, where it's at when it comes to real life stuff. Because how often do you say, I'm going to do exactly that? A lot of the time you're like, well, I want to lose, at least 5 pounds. Or I want to make more than $1 million. Like, how often does somebody say, I'm going to make exactly $1 million. That's it. Like, inequalities are actually very real, like way more real life than equations. Because this is when real life is very similar to this. Because a lot of things aren't exact in real life. Everybody okay with this one? I'm going to show you another. Okay. Alrighty. So draw yourself the same kind of box. For example, number 2. I'm going to give you a lot of information today, if I'm being completely honest, but I'm going to pretty much shut up tomorrow and just let you practice these, so bear with me. Okay, example number 2. I'm going to put the verbal representation of the situation. I want to work less than 70 hours this week. Hashtag teacher life. Between grading and all that, that sounds about right.
So you guys went like 80 hours?
It's really insane. So my goal this week is I'm going to try to shoot for less than 70. Okay, writing the inequality, I feel like is going to be pretty easy for you guys. Because it's just going to be a less than symbol. You're going to say x is less than 70. Why didn't I put an equal sign underneath there? Exactly. I didn't say 70 or less or anything like that. I specifically said less than 70. So the verbal representation is there. The inequality symbol is there. Let's graph it on a number line now, because that is what goes in the top right-hand corner. So 70. Am I going to color my circle? I put my little coordinate, I put my dot around the 70. Am I going to color it in, or am I going to leave it open? I'm going to leave it open. So again, the math term for that is open. Why am I going to leave it open? There's no equal to sign. Okay, 70 is not actually part of what we call the solution set, because anything less than 70 is, but 70 itself is not. So that's why we've got to leave that open circle. It's kind of like a landmark. Like, hey, any number that's smaller than 70 works, but 70 itself is not included. Now, I still need to shade my number line in order to represent the idea that every number on the planet that's smaller than 70 could work. Now, in real life, am I going to work negative hours? I wish, okay? So technically speaking, by shading this side of the number line, I'm technically saying something that doesn't match the real world situation. But in math, sometimes that just kind of happens, that the symbols don't necessarily match up with the real world. So I'm going to color code it. I shaded to the left, and the reason I shaded to the left is because that was a less than symbol. So I left the circle. Oh, and my number lines are really ugly. Sorry about that, y'all. So I leave the circle open because there was no equal to sign in that inequality. And I shade to the left. So for interval notation, that's my last one, and we're going to use the number line to help. Notice how that arrow to the left says you're going forever and ever and ever in the negative direction, right? Notice how last time when we were going forever and ever and ever in the positive direction, we used a positive infinity. What do you think we might do to go forever and ever and ever in the negative direction? There is a negative infinity. Yep. It just means that you're going forever and ever and ever in a negative direction. So the left side of your number line is that negative infinity. It's the left side being shaded. And then the end point, kind of like the bookend, is that number 70. Okay, so you remember how we used a square bracket if it meant equal to? Do you ever use a square bracket for infinity? What did we say about that? No, because it's a concept, so we're automatically going to just make a round bracket. And we're going to do it because it's not equal to. Is 70 included in our solution set? Did we leave that circle open or did we fill it in? Open. We left it open because 70 wasn't equal to, right? So for that reason, on 70, we're also going to leave it because it's not equal. That's really ugly. Let me try that again. Today has, yes, and I had a very long weekend on top of this long day. I'm kind of over it. I'm very sad that we have a 5-day week this week.
Oh yeah, we should have a 3-day week.
All right, y'all. So any questions about number 2? All right. So while we're drawing a box for question, and I'm sorry, I am giving you a whole lot of information today, guys. Sorry about that. But it's okay. Okay. Who's heard the word, what's a compound word? Where have you heard a compound word?
Airplane.
Okay, airplane, right?
Firehouse.
Because it's got 2 words?
Subway.
Great. Okay, thanks, Mikey. All right. What I'm getting ready to give you is an example of a compound inequality. Because you're going to have 2 inequalities all kind of wrapped up into one. Okay? I like vacation. I don't really like it when it's too hot. I also don't like it when it's too cold. So I like vacation when it's between 70 degrees and 85 degrees. Okay? I don't like going when it's too hot. I don't like going when it's too cold. I like it right in between. So it needs to be warmer than 70, but I don't want it to be as warm as 85. I want right in between. So this is an example of a compound inequality. You probably haven't seen one of these the same way that this is usually when the new stuff, you probably didn't learn this in 7th grade when you did inequalities. So here's how you would write it. So X is going to be the temperature I like. Okay. Now, it says between 70 and 80. Does that include 70 and 80? No, it's just the space in between. So I'm going to put 70 on one side. I'm going to put 85 on the other. I want the temperature to be greater than 70, but less than 85. So this is a compound inequality because it's got to be bigger than 70, but smaller than 85, or but lower, I should say, than 85. So on the number line, this is what it's going to look like. I didn't put an equal sign in there. I'm not too picky about your number lines. I'm not really picky about how you like spread out your numbers. As long as I can see them both on there, that's cool. So let's talk. So I'm going to put coordinates around them. So is 70 included? Am I happy with it being exactly 70? Is there an equal sign with that inequality symbol? Is there an equal sign there? Nope. So I'm not going to fill in the 70 because I don't want it to be 70. I want it to be like bigger, like between 70 and 85. So that's not the same thing. Am I going to fill in the circle for 85? Is there an equal to sign to go with that 85? No. So I'm going to leave my two coordinates just like that. Okay? Both of those coordinates are open because there was no equal to sign underneath there. Okay, so I'm going to leave them open because no equal to sign. Remember, open is the word for not filled in. And then I need to indicate on that number line that I'm cool with any temperature in between 70 and 80. So I'm literally just going to color my pencil like that, or my number line just like that. I'm going to darken the space that falls right in between 70 and 80. It's actually easier, I feel like, to do interval notation for a compound because you just do your smallest number and your biggest number. What's the smallest number graphed on that number line? 70. What's the biggest one? 85. Am I going to put little square brackets or am I going to put little parentheses? I'm going to put parentheses, exactly, because those are no equal to. So anybody that looks at that interval should be able to tell me that the solution set is any number between 70 and 85. Last one.
One more?
Yeah, I've got to do one more.
No, we're done.
I told you I'm giving you a whole lot of information today, but I was going to take it easy but tomorrow you just get to practice, but I got to give you a lot of information today, so I'm sorry. Thanks for bearing with me.
No, wait, is this the last one?
This is the last example one, yes.
And then we're done for
There's 4. Well, no, yes, we still got stuff to do.
It seems like it's been long though.
I'm sorry that you feel that way. I mean, on a day when I got to give you a lot of info. Yeah, I can see that. Okay, last one. This is going to be another example of compound. What happens if hamburger meat gets too hot? Like if it's like sitting out. It spoils, right? So it's got to stay a certain temperature or you've got to cook it to a certain temperature, right? Okay, so our verbal. I actually had to Google this because I have no idea about food. Hamburger must be 45 degrees or less. I didn't give myself enough space here. Or higher than 160 degrees. So either it's got to be cold or it's got to be hot. If it gets in between, if you let it sit at if you let it sit there at room temperature, that's when it goes bad, right? If it's too cold. Okay. All right. So that means this is going to be a compound inequality. Can you be less than 45 degrees and higher than 160 at the same time? Can you be cold and hot at the same time? No. Okay. So this one I did up here. You can be between 70 and 85. Okay. That's what we call an and. Higher than 70 and lower than 85. Actually, we should write that right in quote right here that's an and. Because you can be 70 degrees and 85, like between those two. This is what we call an or. Because you can't be cold and hot at the same time. You can't be lower than 45 degrees and higher than 160 degrees at the same time. So as an inequality, this is what you have to do. You have to say x is less than, and it does say it can be 45 or less, so I'm going to put a equal to sign in there. X could be less than or equal to 45. Or you have to write the word or in there because it can't be both at the same time. So it can be less than 45 degrees or it can be equal to or greater than 160 degrees. You can't have it in between. You can't have them both at once. That's why it says or. Okay, here's how you do it on a number line. Even though it's two different inequalities, you're still going to put them together on that number line. Okay, so you've got 45, you've got 60. Am I going to fill in my dots or am I going to leave them open? I'm going to fill them in because they've got what? They got equal to signs in there. Exactly. So we're going to fill them in. So we're going to call this closed because they are equal. But this time we've got to shade differently because it could be lower than 45 or it could be higher than 160. So you're actually going to shade your number line in two different directions. So you're going to shade to the left of the 45 degrees. That's really super ugly. Be quiet. You're supposed to say, no, it's great. Okay? Okay, fair enough. Bless you. And you're going to have to shade to the right because hamburger meat is okay as long as it's colder than 45 or warmer than 160. So you have to shade to the right and the left. So we have to shade to the left and to the right because there's two different possibilities.
Infinity, comma, infinity.
You're close. Okay, so let's talk about why that one won't work. Okay, I put it in red because you don't have any space right there, right? Infinity, comma, infinity means it would be the whole number line, but it's not, okay? So what you're going to need to do, but you're right about the negative infinity part. So we're going to say negative infinity to make up the left side of that bracket, comma, 45, because that's the next number on there, right?
Comma, 60, comma.
Not quite. You should just let me tell you. Okay. First of all, I need to put brackets on either side of that. So for the negative infinity, am I going to put a hard bracket or am I going to put a parenthesis? That parenthesis, right? Because you can't have an exact value to infinity. What about the 45? Hard bracket, because it's equal to. Then we're going to do the same thing for the 60. Okay, make two separate little intervals, because then we've got 60. And then what am I going to put on the right side of that interval? What do you think I'm going to put to make sure that's going to the right forever? Thank you. Infinity. And we're going to put a... So you do two intervals, but then you join them together with a little u in between. That means it stands for union. It means you've got two different intervals, but they technically go together as part of the same problem. Since you can't have just one interval, because either it goes to the left or it goes to the right, you've got to do two separate intervals, and then you've got to put a union like in between them in together to make that work. Okay, now that's all.